In the heart of Dujiazui, Shanghai's financial district, stands one of the most ambitious vertical megastructure in the world, the Shanghai Tower. Completed in 2015, this 632-meter super tall skyscraper rises 128 floors above the city, making it the tallest building in China and the third tallest in the world. With over 578,000 square meters of floor space, it stacks offices, hotels, retail, observation decks, and public zone within a single glass envelope. It's designed to not just function vertically, but to perform efficiently, thermally, electrically, and mechanically, in response to climate, wind, and density of Shanghai. Shanghai Tower's most iconic feature is its twisting form. The building rotates 120 degrees from base to top, creating a helical profile that's functional and elegant. This aerodynamic geometry reduces wind loads by 24%, allowing engineers to cut structural steel usage by 25%, reducing both construction costs and embodied carbon emission by nearly 18,000 tons. The design also eliminates the need for energy-hungry damping system, often used in super talls, saving energy use in mechanical sway control. Structurally, the tower is stabilized by a system of 8 megacolumns that connect to a central concrete core through 2-story deep outrigger trusses. Belt trusses distribute lateral loads across the facade, while radial trusses support mechanical floors. This integrated system not only ensures seismic safety, but also supports consistent internal air pressure, helping the HVAC system operate more efficiently, especially under extreme wind conditions.
Certifications and global recognition. This building has received a top sustainability certifications, LEED Platinum from US Green Building Council. China Green Building the 3-star rating, the highest in China for its double skin facade, energy savings, and wind powder integration. It also holds several Guinness World Records. Let's break down the sustainable strategies powering the Shanghai Tower. Let's take a closer look at the first strategy, the double skin facade. Shanghai Tower features a double skin facade that includes a photovoltaic panels. This design creates a buffer zone of air between the two layers of glass. The trapped air acts as an insulation, reducing heat gain in the summer and heat loss in the winter, which greatly decreases the energy needed for heating and cooling. In addition to its insulation benefits, the outer layers also integrates solar panels, allowing the building to harness renewable energy directly from the sunlight. This facade system plays a major role in reducing overall energy consumption, while also enhancing the daylighting, creating a more comfortable and naturally indoor environment for users. Did you know the Shanghai Tower double skin facade can cut energy use by up to 50% compared to the traditional curtains wall, thanks to the thermal buffer zone between its two layers.
The Shanghai Tower uses a double skin facade system, like a building wrapped in a thermal glass, as to enhance energy efficiency. The inner curtain wall is airtight and cylindrical, while the outer one spirals upward, allowing air to flow through the buffer zone in between. This space hosts sky gardens that purify the air, promote natural ventilation, and create relaxing communal areas. Thanks to the smart facade, the tower reduces energy by up to 25% and proudly holds a LEED Platinum certification. Now, let's explore the impact of one of the key energy efficient strategies implemented in the Shanghai Tower, which is the wind turbines and fuel cells. It is located near the top of the building. These wind turbines and on-site fuel cells are crucial for generating renewable energy directly at the source. So, why is this important? As producing clean electricity on-site significantly reduces dependence on fossil fuel-based grid power. And what's the impact? This strategy supports Shanghai Tower's remarkably low carbon footprint and aligns with China's broader commitment to sustainable energy solutions. Together, this innovation not only power the tower more efficiently, but also set a benchmark for future green skyscrapers around the world. Let's take a closer look at another innovative energy-efficient strategy used in the Shanghai Tower, which is the rainwater harvesting and rainwater recycling system. This water recycling system is especially important in tall buildings with high occupancy, where water usage is significant. By collecting rainwater and reusing greywater, the system reduces the demand for fresh water while supporting broader sustainability goals. Its impact goes beyond water savings, and it also helps the building meet LEED water efficiency credits and significantly lowers operational costs. Smart, sustainable, and cost-effective, this strategy is a great example of how green engineering can meet real-world needs in modern skyscrapers. Next, we look at one of the most critical systems in any skyscraper, the HVAC, or heating, ventilation, and air conditioning system. Shanghai Tower uses a highly efficient HVAC setup that relies on natural gas and waste heat instead of traditional electricity for cooling and heating. These systems use advanced chemical adsorption processes to absorb and release heat, making them much more energy efficient. By doing so, they help reduce peak electricity demand and promote a more stable, sustainable energy usage model. So what's the impact? With over 6,700 water control valves and 660 variable speed drives, the system achieves up to 20% energy savings. Additionally, The tower incorporates natural ventilation. Vents at the top and bottom allow warm air to rise and escape, pulling in cool air at the base, minimizing the load on mechanical hatchback systems. This thoughtful integration of technology and passive design makes Shanghai Tower a leader in high-performance building systems. Here's how the geothermal system delivers comfort indoors. Cool or warm water flows from the heat pump to the air handling unit. That unit then circulates the conditioned air through ducts to every room, including spaces like meeting rooms, keeping the environment comfortable all year round.
Explore thermal storage, a smart strategy that stores excess heating or cooling during off-peak hours, like at night, and releases it during the day when demand is high. This reduces the need for HVAC systems to work hardest when electricity is most expensive and carbon-intensive. The impact is significant. Energy bills go down, strain on city power grid decreases, and building temperature stays more consistent, all of which improve comfort for occupants. By balancing energy loads this way, thermal storage contributes meaningfully to overall energy efficiency in Shanghai Tower. It's a great example of how clever design can make tall buildings smarter and more sustainable. Now, we have the Smart Building Management System, the brain behind the building's efficiency. It minimizes energy and water waste by only running systems when and where they are actually needed. It also enhances comfort and health for occupants by controlling climate and air quality with precision. With predictive maintenance, it extends the life of equipment and cut down operating costs. And thanks to powerful data analytics, the system continually optimizes performance in real time. The impact: significant contributions to LEED certification, seamless integration of all energy systems, and a smarter, more responsive building. It's the kind of intelligent control that helps make the Shanghai Tower a global leader in sustainable architecture. Finally, let's talk about the building's unique twisted form. It's not just a design statement, it's a strategic energy-saving feature. The spiral shape significantly reduces wind loads on the structure. That means the building needs less steel and concrete, cutting down on both cost and material use by around 25%. Improved aerodynamics help wind flow smoothly around the tower, reducing resistance and making the building more stable and energy efficient. And there's another bonus. The twist provides self-shading, reducing heat gain from the sun and further decreasing the need for artificial cooling. This smart design shows how form can follow function beautifully. All these strategies comes together to deliver real results. The tower achieves a 21% reduction in total energy consumption compared to conventional buildings of similar size and use. Even more impressively, these innovations help reduce carbon emission by approximately 34,000 metric tons every year. That's a powerful demonstration of how thoughtful design and technology can lead to both environmental and economic benefits. Beyond the primary system, even the elevators contribute to the tower's energy efficiency. This building features the fastest elevators in the world, equipped with energy regenerative drives. This advanced system not only improves vertical transport efficiency, but also recover energy during operation, demonstrating that sustainability can be built into every moving part. The cumulative result of these innovative strategies is a remarkable environment achievement. This skyscraper has achieved a 21% reduction in total energy consumption compared to traditional buildings of similar scale. Through smarter system, thoughtful design, and cutting-edge technology, the tower stands a symbol of what sustainable architecture can accomplish. The building also harnesses energy directly from nature. With the help of solar panels, high-performance glazing, and green architectural features, it generates clean, renewable energy. These systems work together to reduce reliance on non-renewable sources and ensure a more sustainable future. With the help of solar panels, high-performance smart glass, and green roofs, it generates clean, renewable energy.
Let's take a closer look at the building's carbon emission. During construction, the embodied carbon, which includes emissions from materials and processes, which average 15,911.8 metric tons. However, thanks to energy-saving features, the building reduces operational emissions about 37,000 metric tons of CO2 annually. This means the building offsets more than double its construction's emission every year, making it a significant win for sustainability. At the top of the tower, 270 wind turbines harness the power of the wind to generate renewable energy. These turbines produce average 350,000 kilowatt-hours of electricity each year, meeting around 10% of the building's total energy need. This smart integration of clean energy helps reduce reliance on fossil fuels and lowers the building's overall carbon footprint. To understand the building's energy performance, we look at its efficiency. We calculate this using the formula energy output divided by energy input, then multiply by 100. This gives us the building's energy efficiency percentage, a key to measure how sustainable the tower operates. But that's not all. Below the surface, geothermal systems play a powerful role. Using a ground source heat pump, the building optimizes heating and cooling, cutting energy use and CO2 emission even further. It's clean, quiet, and incredibly efficient. Let's take a look at how different heating systems compare in terms of energy usage. As shown in the bar chart, gas furnaces and matrix heaters are the least efficient, each using nearly 100 units of energy to provide the same amount of heating. Next, air source heat pumps are a bit better, using around 70 units of energy. This massive reduction in energy use doesn't just help the environment, it also means much lower energy bills. Now, look at Shanghai Tower beside me. Imagine how much energy such a tall buildings would need for heating and cooling. By using efficient systems like GSHP's building, like this can cut down a large portion of their energy costs while also contributing to a greener future.